Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question. Letter combination of the phone number. Okay. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. Given a string inclusive, return all possible numbers. Number could represent. A mapping of digits to letters, just like on the telephone button, is given below. Note that one doesn't map to any letters. So I'm given, say, 23 to 3. In that case, 2 can represent any of ABC, a single letter, and 3 can represent any single letter, D or E or F. So it should be AD or maybe AE, AF, BD, BE, BF, CD, CE, CF. Every combination of ABC and DEF. Okay, so let me clarify the question statement more. So in this question, I'm given string and I will return list of numbers, or I should say list of integers. Yeah. And this string is, list of strings. This string is actually represent number, or I should say this should be digit string. Okay, like 1, 2, or 1, 2, 3. Yeah. And I return string. Okay, I'd like to clarify something. Number one, I understand that the string, each letter is digit, but could it include 1 or 0, which doesn't represent any character? And I will check the constraint. And this is yes, 2 to 9. So 1 and 0 is not included. Okay. Aside from that, yep, everything is clear to me. Obviously, if the length of the string is 0, I should return empty array because this doesn't contain any letter, any digit, which means that it mapped into empty. Wait, do I have to return empty string? Probably yes. Oh, I have to take care of this maybe. Yeah, maybe this is the edge case. If length of the string is 0, which means that I'm given empty string, I should return an array which includes only an empty string. Okay, I've clarified the question. So let me think with some examples. So let's say I'm given 2, 5, 6. I think this is quite, obvious. Firstly, I can choose A or B or C. Then 5 represents J, K, L. And 6 represent M, N, O. Yep. So I will create any string with the combination of this or this or this, this and this and this. Yeah. Okay. So as the brute force approach, I will do the, say, recursion. Yep. And firstly, for 2, I choose A or B or C, and then with that string, I will call 5 and then 6. And every time I get into the recursive function call, I append the new character. For example, for the second recursive call, I append J or K or L to the current string, or I should say string so far. And in the end, when I reach 5 and then 6, and appending M or N or O, I've completed the string. So I put it into the global list of a returned array and finish the iteration. So it should be assuming that there are 3 characters for each digit. Sorry, I will take the upper bound, so there should be 4 characters, which is mapped from single digit. I will do this recursive function call 4 to the power of n. Then for each, I have to append the new character into the string, and this takes all of n time in Python because I have to initiate the completely new string. They should be like this. And then after creating the string, I will append the global list. But it takes only the constant time because it just list has a pointer to the new string. So the time complexity should be like this. Okay. But I think I can optimize this up with using backtracking. So I don't have to initiate the new string in each every call, API call. Instead, I will just keep track of the child so far. Yeah. And I will append the chars into this kind of global array. And when I reach the final character, builds the string, append to return that list, which should be global across the recursive functions. Yep. So with this idea, the time complexity should be 4 to the power of n, and I don't have to do this. But for every end of the recursion, so there should be 4 to the power of n string, and I need the time to initiate this. Yep. So this should be the time complexity. Wait. No. Yes. So the time complexity should be this. Yeah. Sorry. But I noticed that this isn't correct actually. Because the recursive function is not this many. It's more. It should be like this. So number of the recursive functions should be firstly, let's say for the first character, it should be 4 recursive function calls. And for each, for the second recursive function call, whose depth is 2, there should be 4 to the power of 2. And then for the third depth 3 recursive function call, it should be 4 to the power of 3. So the total number of recursive function calls should be this. 4 to the power of 1 plus 4 to the power 2 plus blah, 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 for the n. And I multiply n to this sum. So actually, yeah, this is much more than 4 to the power n times n. And with the backtracking, it is, minimized to the 4 to the power n times n. And I'm pretty sure this is the best time complexity I can achieve because I have to return every possible generated versus a converted string, which should be 4 to the power n strings, and each have n ranks. So just initiating those return string takes 4 to the power n times n. So I can't achieve any faster than this. I'm pretty sure this is the best. Okay. With the space complexity, Charles Sulfur takes n. And aside from this, the recursive function could be up to depth n. It should be n. And that's it. I don't include the returned. Oh, sorry. And one more thing. I have to initiate the returned each string, which takes O of n. Yeah. But I don't include the returned width as the extra space complexity. So I don't have to include 4 to the power of n times n. No, n times n. No, 4 to the power of n to n times n. So the space complexity should be O of n. Okay, that being said, let me get started with the implementation. But let me quickly identify the recursive function interface only here. So I will put the index in the string, given string, and yeah, that's it. What I will do is append to child software, call convert with i+1, and revert the changes to child software. Obviously, for the base case, if the given string is created, I run out of every digit in the given digit string is the base case. In this case, I will build the string and append to the returned list. Okay, that being said, I start my implementation. Okay, so in the helper function, and this is about the base case, so if not, So I need the mapping from digit to each character. So digit to letter. I will do this right here. So it means so here current digit is this. For each current letter, I append the current letter to this. Then recursive function call. Then rollback. Yeah, and that's it. Okay. I think this is good. Let me quickly check again. So in the main method, self.combinations is the returned array in the end. And chart solver is something where the letter solver are stored. And for convert, this is the recursive function. Yep. So in the main method, I called the convert function with first index 0. And in the end, after finishing the recursive function calls, I return self combinations list. Okay. And in the recursive function, this is the line 52 is the base case. If I run out of all the given digits, I convert the char software into the string and I append it to the returned list combinations and finish. Otherwise, current digit is converted into the letter. And this current letter is appended to the char software and calls the recursive function call. And after coming back, I wrote this back because this is backtracking. Okay, good. So let me quickly add this. So let me do this right there. I will prioritize dry run first because adding something here is quite trivial. Nobody can do. ChatGPT can do. Okay, so for dry run, let's start with A, B. Sorry, let me start with the empty string case. In this case, this is expected. Okay, so for empty string, self.digit is initiated. Char software begins with empty array, and combinations is obviously initiated with empty string, empty list, and self.convert 0 is called. Yep. And when I is 0, length of the self digit is 0. So in line 64, this is true. I go to line 65 and empty string join self.char software. Char software is now empty array. I actually don't know if this is possible. Join can get empty array. Just in case, let me do the if condition check. Maybe this isn't necessary. This is the I will take care. Mm-mm. Yep. So let me just make it single string, single line. Okay. So now found is empty string because rank as a child software is 0. So save the combinations, append empty string. So this is now empty string only. And I return. I come back to the main method and I return save those combinations, which is an empty, which has only the empty string. Good. This is as expected. So I pass this test case. I will check one more test case, AD, which has two characters, one from each from other digit. Okay. So in this case, save the digit. I clean this up. Is obviously just AD, and I initiate this to list and go to convert method. Yeah, 0. So if I is equal to rank save the digit, which is 2. So this is not true. I go to line 69. Current digit is third digit I, which is A. So this is mapped into oh no, I should be given digit. So let's say 12. 1, 2. The current digit is 1. So this is mapped into ABC. And for each current letter, I will check if the case is A. Current letter is A, so this should be appended to child software. And now I call serve.convert I plus 1, which is 1. Yep. Here, I, which is 1, is not equal to 2. So I go to line 70. And current digit is now, oh, sorry. 1 is not mapped into ABC. 2 is. For my carelessness. I take 2 first. And let's say I'm checking 3. So this 3 should be mapped into DEF. And first I go with D. So current letter is D. So child software is now AD. Yes. And I call self.convert with 2. And because I is equal to 2, which is self the digit ranks, so I build the found letter as AD, and I append it to combinations. Okay. And I come back to line 44, and what happens is that I pop out this D, and I check E, and probably we get AE, then come back and pop out E from the child software, and instead I will append F, and I can build AF. Yeah, so I think this works as expected. I don't cover all the cases, but so far I can say I covered all the lines in my implementation. I'm pretty confident in my code. Okay, good. Let me just update this mapping and run my code. Four, five, six, seven, eight, nine. 4, 5, 6, 7, 8, 9. G H I J K. Okay, and I submit my code. Okay, self dot. Oh, so if digit is empty, I'm not expected to return empty string list. Yeah, so obviously this is, my first. Oh, I can find it in example 2. In this case, I should return empty list. Okay, this is just I took the clarification in the wrong way. So I think I can do it here. Yeah. And if I do, sorry, or maybe I can just array return first if this case. Yeah. If I do that, I can say length of the digit is 1 or larger. So I don't have to take the former case. Yeah. Good. Okay. Submit again. Accepted. Accepted. Good. Okay, let me quickly wrap up. So today I solved the question, relative combinations of phone number. So this is a hard question, very medium. I just had to do the typical backtracking. Yeah. So I was given the string, which composed of the digit, and I will convert it into the string. Each digit has a mapping to the list of characters. So I apply each digit, the conversion to any of the character. Yeah. So I use the backtracking. So each recursive function is responsible for converting the specific character in specific index. Yeah. And I append it to the child software. Yeah. As the base condition, if child software, if I've exhausted all the characters in the given digit string, is the base case, and I build the converted string and append it to the returned global list. Yep. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.